Hello and welcome back. In this lecture, we're going to delve deeper into Newton's laws. Specifically, we are going to study Newton's second law of motion. The first law of Newton gave us a qualitative understanding of motion, in that any object will retain its state of motion unless and until an external force is exerted on that object, all right, to change its state of motion. Newton's second law, however, puts force on a more quantitative or mathematical basis, in that it gives us a formula to calculate forces. Okay, so this second law relates forces and acceleration. Okay, so it relates dynamics and kinematics, in that we know acceleration was a kinematic variable when we studied kinematics. Forces we just got into to explain the why of kinematics, as in why things move the way they do, which is dynamics. So force is a dynamic variable. Newton's second law is read as follows. It tells me that the summation of all forces on a particular object is equal to the object's mass times the acceleration that this summation of forces causes for that object. Okay, we would note that this is a vector equation. Since force is a vector, acceleration is also a vector. So we have to be extra careful when summing forces. So this sigma sign basically tells us to sum all the forces on a particular object. Okay, so we call this the net force is equal to the mass times acceleration for that object. All right, and from this definition we can understand mass as follows. If we rearrange this equation, we find that mass is equal to the resultant of force, or the summation of all the forces on that object, divided by the acceleration that resultant force causes. This means that the mass is inversely related to acceleration. So basically all of that mathematical notation just means that the more stuff you have in an object, which is basically our understanding of what mass really is, the amount of stuff in something, the harder it is to make that object accelerate. So the more mass you have, the lesser acceleration can be caused by a particular force. Okay, so in essence, the more mass you have, the more force will be required to make that object to accelerate more. All right, physically, mass is understood as the property of any object to retain its state of motion, and we call this property inertia. So what inertia does is, more inertia or more mass an object has, the more ability that object has to resist changes to its state of motion, or similarly resist acceleration. All right, and physically then mass is a measure of the inertia of an object, and SI unit of mass is kilograms. Let's look more closely at Newton's second law equation. This is, as we have discussed, is a vector equation, since F for forces is a vector quantity, and acceleration, as we know, is also a vector quantity. So like any other vector, A and F can have two components, one a horizontal component, another a vertical component. We call those X and Y components, like we did in kinematics before. That means that this equation will have two components to it, or two parts to it. The x part would be written as summation of fx equals m times ax. This equation will have all of the vector quantities along the x-axis. So all of the forces in the horizontal or x direction, and all of the acceleration in the horizontal or x direction. This y equation will have all of the forces in the y direction and all of the acceleration in the y direction. However, in both cases, you will notice the mass would be the total mass of the object, because mass, the measure of inertia of that particular object, is a scalar quantity. It is fixed, it doesn't change. To understand more about it, let's look at an example. The question reads, we have a box of 1.2 kilograms on which 4 forces are acting. The forces are as follows. We have a force of 50 newtons at 25 degrees above the positive x-axis. We have a force of 35 newtons at an angle of 70 degrees above the negative x-axis, a force of 10 newtons in the negative y direction, a force of 3 newtons in the positive x direction. And the question asks me, what is the acceleration of the box if there is any? First thing we do is we attempt to draw the free body diagram. Without free body diagram, you cannot solve Newton's law problems, and without free body diagrams, mostly you cannot solve any physics problem from here on. Okay? At least involving kinematics and dynamics. Alright, so first, free body diagram. This is our initial job. We have the box as follows, and let's say it's resting on a horizontal surface. So this is my positive x-axis, this is my positive y-axis. So it is very important to define my axis either on the side here or through my free body diagram, it really doesn't matter. Then we have to note down the different forces on it. So let's do that. We have a force of 50 newtons at an angle of 25 degrees above the x-axis. This is the x-axis. Above the x-axis means that the angle is formed here, around here somewhere. So let's say this is 25 degrees above the x-axis, okay, and the force is going like that. We call this force as magnitude of 15 newtons. All right, the second force is a force of 35 newtons at an angle of 70 degrees above the negative x-axis. Since going rightward is positive, the negative x-axis is just going leftward. So from the origin, we would have an angle of 70 degrees with a 35 Newton force. So that would look something like that. And the angle is above the negative x-axis of 70 degrees. Okay. And this has magnitude of 35 newtons. All right. Now the third force is a force of 10 newtons in the negative y direction. Negative y going upward is positive y, so negative y direction would be going straight down, and this has magnitude of 10 newtons, so it will be slightly smaller than both of these other arrows because vector is showing us both size and direction. So this has magnitude of 10 Newton directed straight down. The fourth force is we have a 3 Newton force in the positive x direction. So this is a completely horizontal force along the positive x-axis with magnitude of 3 newtons. So we have 1, 2, 3, 4. 4 forces. Now let's make some space and carry out Newton's second law solution. Alright. Now let's remind ourselves what Newton's second law looks like. Newton's second law equation is this: F equals summation of F equals ma. This is the complete equation. Now we have said that this is a vector equation with two components to it, the x component and the y component. Why are they important? Because vectors, if you want to add them, you have to add them consistently. So you can't add an x vector to a y vector. You have to do x to x, y to y. So as we can see from the diagram here, from the free body diagram, that we have multiple forces directed in multiple directions. So we want to only add x to x and y to y directions. Alright, so that's why first of all we have to break this down into its components. So we will investigate the x Newton's law equation and the y Newton's law equation separately. Before moving on to there, it is integral that we find out all the x and y components of all these different forces. So let's look at each force separately. So let's look at the first force, which is a 50 Newton force directed like so over the positive x-axis at an angle of, so this is plus x, this is plus y, at an angle of 25 degrees. What are the components of this? The components are, as we should know by now, will go this way. This will give me the x component, and it will go like this to give me the y component, and together they will form a right angle. This will help me find the x and y components. So let's call this y1, let's call this x1. What is y1 and x1? y1 is the y component of 15 Newton force, and x1 is the x component for the 15 Newton force. All right, so since we have done problems involving these component calculations before, I would just write them down, and I expect you to work it out on your own. We have the x1, or the x component of the 15 Newton force, is x1 equals 15 times cosine of 25 degrees. y1 is equal to 15 times sine of 25 degrees. Now let's look at the second force, which is directed like so, with a magnitude of 35 Newton and a direction of 70 degrees over the negative x-axis using the same chosen axis. Then our components would be, the x component would be going left, the y component will be going up. So let's call this x2 and y2. So what is x2? x2 is 35 cosine 70, y2 is 35 sine 70. What about the other two forces? Well, we have a force that is going straight down. This is only the 10 Newton force, and this is a fully vertical force, meaning it doesn't have any x component. And also we have completely x force, which is 3 Newton, meaning it doesn't have any y component. All right, so these are the forces, and now that we have found the components of all these forces in the x and y directions, we are free to evaluate our Newton's second law equations for each direction independently. Okay, now let us write down the x equation first. So we have summation of fx is equal to m times ax. The left hand side of the equation must have all of the forces summed together in the x direction, which gives me how many x forces there are. We have x1, we have x2, there is no x forces for the 10 Newton vertical force, and then we have a completely horizontal force, which is 3 Newtons. So we have 3, x1, x2 and 3 Newtons. These are the different x forces or horizontal forces. So when we sum, we have to remember, we have to consider directions as well, since this is a vector. So x1 was directed along the positive x-axis, hence it is a positive vector. So we have 15 cosine 25. To that we add x2, but x2 was directed in the negative x direction. So we have negative of x2, which is 35 cosine 70. And then we move on to 3 newtons, which is directed in the positive x direction. So we have 3. This is the left hand side of the equation. This is equal to m times ax. The mass of the box was 1.2 kilograms times ax. We don't know the acceleration in the x direction. All right. So from here we can see that we have one unknown, which is the acceleration in the x direction. So we can actually calculate this acceleration. 15 cosine 25 minus 35 cosine 70 plus 3. Then we divide both sides by 1.2, which gives me the acceleration in the x direction. So ax turns out to be negative 0.75 meters per second squared. This negative just tells me that acceleration in the x direction is along negative x-axis. So the x component of acceleration is directed along the negative x-axis. Now let's move on and similarly write down our equation in the y direction. For the y direction, we have summation of f in the y direction is equal to m times a in the y direction. In the y direction, what are the forces we have? We have y1, which is directed upward, so a positive direction, 15 sine 25. We have y2, which is also directed upwards, so positive again, plus 35 sine 70 degrees. Then we have 10 newtons, which is directed vertically downwards, so a negative vector, negative 10. This is equal to the mass of the box, which is 1.2, times ay, acceleration in the y direction. Similarly, like the x case, we can find ay from here by dividing both sides by 1.2. If we do that, we find ay comes out to be 22.2 meters per second squared. So we have found ax before, and then now we have found ay, and the sign here is positive, meaning the y acceleration or y component of the total acceleration is directed in the positive y direction, while the x component of the total acceleration is directed along the negative x direction. So if you remember from our work with vectors in projectile motion and any kinematics, to be fair, we will realize that we are not done, because we have just found individual components of the acceleration, while our ultimate goal is to find the total acceleration of the box, given that these 4 forces are acting on it. Okay, the total acceleration would be the magnitude of the y component and the x components of acceleration. Okay, so always be careful about what the question is really asking for. So let's go ahead and solve for our total acceleration. So the first thing we do is we draw an axis again. The positive y going upwards and positive x going rightward. This is our axis. Now what were my x and y components of acceleration? X component was negative 0.75. That means we had the acceleration x component going along this direction, which is point of magnitude 0.75 meters per second squared. Okay, so the direction is to the left, while the magnitude of the x component of acceleration is 0.75 meters per second squared, and the y component was 22.2 and positive. Okay, so going upward with a magnitude of 22.2 meters per second squared. So this forms a acceleration triangle similar to what we did with velocity in kinematics. And you can do this with any other vector, not only acceleration and velocity. So this is the resultant acceleration, the net acceleration that appears in the complete Newton's second law equation, and we are to find that. And the angle subtended by a net and the x-axis, or the negative x-axis to be more precise, will be the direction of the net acceleration. So how do we find net acceleration magnitude? Pythagoras theorem. So a net magnitude is equal to square root of ax squared plus ay squared. Ax is 0.75, ay is 22.2, and this comes out to be 22.2 meters per second squared. This is because the 22.2, the y component of acceleration, is way bigger than the x component of acceleration. So it is not a general result. It will not always be the case. It is just true for this problem. And the direction can be found using tangent. So if you consider this triangle, then we have tangent theta equals opposite, which is 22.2, over adjacent, which is 0.75. Then theta is inverse tangent of 22.2 over 0.75. This gives me an angle of 29.6 degrees. And more precisely, if you think about this as north, east, west, south, this angle is directed north of west, right? So we say 29.6 degrees northwest is the direction, and 22.2 meters per second squared is the acceleration, or the net acceleration of the box on when the box has these four forces acting on it. I hope this makes the discussion a little bit more easier.